So hello everyone, welcome back to LeetCode Daily. In this particular video, we are discussing LeetCode Daily problem of the day. The problem is remove all occurrences of a substring, and now we have to given two strings s and part, and we have to perform the following operation on s until all occurrences of the substring part are removed. And this is our condition for find the leftmost occurrence of a substring part and remove it from s. And now we have to return s after removing all occurrences of the part. And now this is the definition of substring. So now let's look at their problem statement. Then we have to further looking their example test cases and their coding implementation part. So now in this problem we have to given a string s and part, s comma part, and in this string s is the main string, our main string, and this part is a substring that we can this part is a substring that we need to remove repeatedly, like when we have, let's suppose this is abc. Okay, and now this abc we have to check with on this main string, and after abc removing from this main string, like how many times this abc is present, then we have to remove abc like two times, like here and here. So then we have to remove this abc from this main string. Then after all operation, the remaining string we have to return it, like let's suppose a. This is our remaining string, for example. Okay, so this is the simple s and part, like these operation we have to perform here. And now our task is to find the leftmost occurrence of part in s and remove the occurrences, and repeat these 1 and 2 steps until the part this part string is not present on this string. Then we have to repeatedly work on their removing part. Okay, removing section, like leftmost occurrences we have to remove it here. And now after this we have to return the final string, like after removing their part string, okay, on their main string. And now let's look at their this meaning of substring. And the meaning of substring, first, the substring is a contiguous sequence of characters with a string. Like you can say an example of a b c d e, and this is our string. And now the substring can be make it like a b c and b c d and c d e, and this is our contiguous substring. Okay, and now a let's suppose ace, this ace is not a valid substring, because since it skips, like ace is skip this b, and here e is skipping d, so that's why this is not our substring. Okay, and now our goal is we have to remove all occurrences of a part from s, this part from s. And after removing this one, always removing the leftmost occurrences, which is first, and we have to repeat these process until the part is no longer found in s, like this part is not present in s after removing all operations. Like if we have removed let's suppose dac, okay, dac from string s, and after removing dac from using a substring, okay, after substring, if no any strings are present on this type of a bac, so then we have to return the string s, like remaining string s. So now let's look at their example test cases. So in first example we have to given this string, and the part is abc. So now first we have their daa bc baa bc d c. Okay, and this is our string, and now the part is abc. And now we have to step by step we have to remove it here, like we have to found this abc on this string. And now first we have this a sorry, this daa, and this daa we cannot get any, like sorry, this d we cannot get this part part, and now again DA we cannot get any part, and then DAA we cannot get any part. So now in next iteration we have A not getting, AA we cannot getting, and again AAB we cannot getting. Again the next step we have there A, then ABC, sorry AA, AB, and then ABC. So now we have to getting our part string on their actual string. Okay, and now ABC we have to found it here. Which index? Index 2 we have to found ABC, because this is 0 1 and 2, and now so on 3 4 5 6 7 8 9. Okay, and now after this we have to remove index 2, this index 2 which assign with value ABC, and now after remove it from here, now what we have to get? DA DAB AABC B. Okay, now this string we have to get after removing this ABC. Okay, now again we have to follow this process, and again here first we have there this D, and again this DA and this DAB. Now we cannot get any string. Okay, and now again we have to follow another, and again we have to here A and B and A. We cannot get any string part here. Okay, and then this B A we cannot get anyone, and again we have to iterate with A B B, we cannot get anyone, and now again this A B and C we can get one more string which is related to our part string. Okay, so which index? This one is 0 1 2 3 4 5 6 7 8. Now fourth index we have to get again a part string on our actual string. So now we have to remove this ABC. So now after index 4 we have to remove. What we have to get? We have to get a DAB and then like DAB ABC. Okay, DAB ABC. Okay, now we have to get another string, another updated string. Now we have to check with another condition, like here D and then B and then B we cannot get. Again we have to iterate with this A, this B and this A. Again we cannot get. Again we have to iterate this B A B, we cannot get. Again now we have to getting this ABC. Okay, which index? 0 1 2 3 4 and 5, and now we have to remove it from this third index, index 3. After index 3 we have to remove this one ABC. This ABC we have to remove it here from the third index. Now what we have to get? D A and B. DAB is our answer. Like you can say ABC is no longer exist on this string S, so we have to return this DAB. So now how many steps we have to follow? We have to follow like multiple steps we have to follow, but the part string, how many steps we have to get a part string? 1 and 2 and 3. Okay, and now we have to return the last, what we have to get string? DAB. Now DAB is our answer. So same thing we have to performing here, and now this one is AX XX, and now we have to remove XY, and after removing XY we have to follow all these steps, and then we have to check with all the substring, and then we have to remove it from here. Okay, and now after this we have to get A and B. So I hope you understand the explanation, like how we have to remove it from our actual string by using part string. Okay, and now the constraint we have to given here, and this is for like s dot length less than is equal to 1000, and now s and the part string, and the same for here, and the s and part string max length is 1000, and the it means like brute force with O of n square complexity is not optimal solution. O of n square is not optimal. And now we have to approach this problem by using O of n log n, or you can say O of n solution. It is feasible for by using these constraints for passing this constraint like O of n log n and O of n. You can solve it for these time complexity solution. Okay, and now the brute force solution of this code is, first we have to check with brute force solution. The brute force solution is what we have to do, we have to find the part from the string s. Now what we how can we find? First we have to a loop of while loop of s dot find, and this s dot find of our part is not is equal to string of n position. And after this what we have to do, we have to erase the part, like when we have to get our part string on our string actual string, so then we have to erase it from here, like s dot erase s dot find part dot length. Okay, so now we have to erase it from our actual string, then we have to return s after all operations. Okay, after follow all operations. And now the complexity of this code is, first we have to find our find function. This find function is O of n time, and again we have to erase function is O of n time, and the total time complexity of this code is O of n square, and the space complexity of this code is O of 1. And now this is a brute force solution for like whenever we have to find a part for one by one we have to checking, and then we have to erase it, like we have to follow all the conditions, then we have to find like we have to erase from this s by using s dot erase. Okay, and now this is not feasible solution for this problem statement. So now let's look at their optimized solution. So this is our optimized solution by using stack. So how we can solve it solve it by using stack? So first we have their stack to process the string. Here we have to process the string of st, and this st we have to process all the strings like by using stack, and then one for loop for iterate through their string characters, and then we have to push it from the current character onto the stack. And after this we have their stack stk. This stk is using by using a temporary stack to check the part, like we have to checking our part here. And then this if condition is basically for we have, if the stack size is greater than or equal to our part, we can check. Okay, we can check it for our condition. And after this we have their j tracks the position of s and k tracks the position of part. Okay, here j is track our position of s, and this k is our position tracks by using our part. And then we have our while loop, and this while loop is generally for store the character in a temporary stack. Here temporary stack, and now we have to pop it, like we have to remove it from the main stack, and then we have to move the previous character in a part in our part. Okay, and now after that we have their this stack dot size not is equal to m. It means if we didn't find the complete part, we have to restore the character, and we have to again back the same process we have to follow it here. Okay, and then we have to push it all the characters back in the main stack, and then we have to pop it here. And again now the convert the stack into our string, this string answer, and then this while loop for generally used for retrieve our characters from a stack. Okay, after all operations. Okay, and then we have to reverse the string as stack stores the character in a reverse order, then we have to use a reverse of answer dot begin and answer dot end, and then we have to return the final string. like after removing all these operations, like we have to remove uh, like this is our part, and then this part we have to remove by using s. So all these steps by using here, and then after stack we have to store the elements, and then we have to remove it here, and after this we have to reverse our answer. So then we have to return it here. Okay, so now let's look at their dry run, like how actually we have to get the dry run is. First we have DAA BC BAA BC DC. Okay, this is our string. We have to here, and the part is our ABC. Okay, and now the stack is basically for the stack is we have to push all the characters onto our stack, and the stack is now once again this DAABC and BAABCB. Okay, and now we have to check ABC on our stack, and we have to remove it from here. Okay, and now after this we have to find our indexes. This is 0 1 2 3 4 5 6. Okay, and after all operation, what we have to get, we have to get like this ABC. This ABC is which index? This second index. We have to remove it from here. Okay, we have to remove it. Like you can follow step by step process, but I can only show like how a stack is actually work. Okay, and now this ABC we have to remove it from here, and after ABC we have to remove. First we have to check ABC. Okay, here first we have to check ABC, and after check we have their uh, remove condition, and after remove our stack is DA BAA BC BC. Okay, and now again we have to check ABC, and now here we have to get like here we have to get ABC again, and after remove it here, remove what we have to get DA BA and BC, and now this ABC we have to again remove, and what we have to get DAB. Okay, and now so you can follow this stack. Also you can push it on here, and then pop it from here, like when you have to get A, and then again you have to check the next character of, let's suppose, B, and then again the next character is D. You cannot process this path. Okay, and this condition. Okay, so you can one thing is you can follow is here, like the part, like this part, and the last character of the part is C. You can mark it as a main character. Okay, this C and this C and this C. Okay, after why we have to use this one, like you can say when C is present, then we have to check their previous values, like what we have to get previous values B and A, and if it is match, then we have to return it here. Like it is a simple approach. Okay, and the time complexity of this code is we have their O of n solution, because of each character we have to push and pop at most once, and the time complexity of this code is O of n, and the space complexity of this code is O of n, because we have to use a stack, and this is the O of n space complexity. And now I hope you understand the logic and the implementation part of this code, like how we iterate over the string, and how we build our output, and how we initialize our stack. Like this again recap, and this st is basically for used to process our character, and this stk is used for our temporary stack to check our part. Okay, and after this we have to iterate this one. Okay, st dot size greater than is equal to m. It means we have to check if the top of m characters into our part, like into our part, and then we have if like part, and if it is match, then we have to perform all operations, and if they do not match, then we have to remove, and then we don't restore. Okay, we don't restore, and then we have to build our output by using this answer. And I hope you understand this reverse condition, because let's suppose we have to get BAC, and now we have to find CAB, then we have to reverse it from here. Okay, and I hope you understand the logic and the implementation part, like how actually we have to work in brute force solution. Actually what we have to get, we have also looking for their brute force solution and their optimized solution. Okay, so thank you everyone, thank you so much.